Hello everyone, I am Ivy Joy L. Altizo.
I'm Carlo G. Valdez.
I am Robbie Guerreira Ramos. Today, we will discuss the ratio test.
Ratio test. The ratio test tells you whether a series converges or diverges. So, kung ang series is converging, it settles on a certain number. However, if it is diverging, it does not settle on a certain number. It is recommended for series that has exponential functions or n factorial. So, mo siya ang mga examples nga na ay exponential functions or factorial o kung dili, both of them ay naa. The ratio test is represented algebraically as R is equals to limit of absolute value a sub n plus 1 all over a sub n as n approaches to infinity. This formula can also be written like this. L equal to limit of absolute value of a sub n plus 1 over 1 multiplied to 1 over a sub n. Kani ikaduha na to nga form sa formula is ato alang gibulag ang a sub n plus 1 all over a sub n para mas dali i-evaluate ang usa ka given. The denominator a sub n is the original sequence, the one given in the question. For the numerator, a sub n plus 1, you are adding plus 1 everywhere you see an n. So, sa ato ang based na sa ato ang explicit formula nga i-provide. Rules in concluding if the series is converges or diverges are according to Paul Dawkins. If L is less than 1, then the series is convergent. A convergent series means that the infinite series has a finite sum. So, kung ang limit is equal to less than 1, ang limit nato is mas gamay siya sa 1, then the series is convergent. If L is greater than 1, including infinity, then the series is divergent. This means that the infinite series sums up to infinity. So, kung limit po nato is greater than 1, apil ang infinity, then the series is divergent. If L is equal to 1, then the series could either be divergent or convergent. This means that the ratio test fails and would require a different test to determine the convergence or divergence of the series. So, kung ang limit is equal to 1, it is either divergent or convergent. So, ang ratio test is not suitable to use to apply sa kana nga certain series.
So guidelines for finding limits, and this is based on the Khan Academy. So first is if the degree of the numerator is less than the degree of the denominator, then the limit of the rational function is 0. So this means if mas gamay o degree si numerator and mas dako si denominator, then ang limit sa function is 0. Second, if the degree of the numerator is equal to the degree of the denominator, then the limit of the rational function is the ratio of the leading coefficient. So, if ang degree sa numerator o degree sa denominator is the same, no? So, the limit is the ratio of the leading coefficient. If the degree of the numerator is greater than the degree of the denominator, then the limit of the rational function is infinite, no? So, if mas dako si og degree si numerator, then gamay si denominator, then ang limit is infinite. So, let's go to the ratio test example 1, no? So, our example A is the infinite sum of 2 to the power of n all over n factorial as n is equal to 1. Step 1. Find a sub n and a sub n plus 1. So in our a sub n, just copy the original sequence, which is 2 to the power of n all over n factorial. And our a sub n plus 1 is just add 1 in every n. So our a sub n plus 1 is equal to 2 to the power of n plus 1 all over n plus 1 factorial. Then step 2, substitute the value of a sub n and a sub n plus 1 to the formula. So our a sub n plus 1 all over 1 is 2 to the power n of n plus 1 all over n plus 1 factorial. And our 1 over a sub n is, take the reciprocal of en, then substitute to 1 over a sub n. And the reciprocal of this is n factorial all over 2 to the power of n. Then step 3, simplify using algebra. So diri atong ibulag-bulag nato ang mga term no para maka-cancel ta. Since ato ang sa 2n plus 1 no, atong gibulag siya para ma-cancel out nato si 2 to the power of n sa denominator. So using exponential rule no, we come up with 2 to the power of n multiplied to 2 to the power of 1 or 2 na siya. And diri sa denominator sa first term nato is n plus 1 factorial is same with the n plus 1 quantity n factorial. Para ma-cancel out nato ang numerator nga n factorial. Then cancel out nato si 2 to the power of n o 2 to the power of n. Si n factorial pod sa numerator o sa denominator. Then nabilin nat sa ato is 2 all over n plus 1 multiplied by 1 over 1. Then simplify, ang mabilin sa ato nga simplified form is 2 over n plus 1. Then step 4 is evaluate the limit. Pag evaluate sa limit, magamit nato tong kuan ni kan gaina nga tulo ka buok. So sa ato ang simplified form is ang naaray variable is si denominator. It means nga mas dako si denominator og degree compared sa numerator. Therefore, the limit is 0. So our r is equal to 0. Then step 5, understand the result. No, so our r is equal to 0. Then 0 is less than 1. Therefore, our limit is less than 1. Then step 6. So make a conclusion. No, so let's go back sa conclusion. No, let's go back to the rules in concluding if the series is converges or diverges. Since our limit is less than 1, therefore we can use this first rule. No, if L is less than 1, then the series is convergent. A converging series means that the finite series has a finite sum. So our conclusion is, since the value of limit is 0 and it is less than 1, therefore by the ratio test, the series is convergent. This means that the series has a finite sum. No, so ang series nato nga 2 to the power of n all over n factorial as n is equal to 1 is convergent.
So next, our example number 2. So the infinite sum of 9 to the power of n all over 2 to the power of n plus 1 times n. So for our step 1, we will find the value of a sub n and a sub n plus 1. So our a sub n is equals to 9 to the power of n all over 2 to the power of n plus 1 times n. Then our a sub n plus 1 is equals to 9 to the power of n plus 1 all over 2 to the power of n plus 2 times quantity of n plus 1. So nainganin ni siya since kaya ato ang kaning n pangdungagan lang nato siya plus 1. So kaning sa 2 to the power of n plus 2, since gidungagan man nato siya plus 1, so na 2 na siya. So plus 1, so na n plus 2 na siya. Then same aning n plus 1. Next, we will substitute our values of a sub n and our value
of a sub n plus 1. So, ing-ani na siya. So, r is equals to the limit of the absolute value of our value of our a sub n plus 1. So, kani siya. So, 9 to the power of n plus 1 all over 2 to the power of n plus 2 quantity n plus 1. And then, our value of a sub n, maano ra siya, ma-reciprocal, since ato ang formula man kay 1 over a sub n. So, mahimo na siyang 2 to the power of n plus 1 times n all over 9 to the power of n. Next. So, para makancel nato ning 9 to the power of n, then our 2 to the power of n plus 1, ato siyang ibulag. Tani, ibulag nato. So, mahimo na siyang 9 to the power of n times 1, since naa po ni siya degree diri nga 1, then, our 2 to the power of n plus 2, ibulag po nato siya. So, mahimo na siyang 2 to the power of n plus 1, then times 2, na po na siya degree nga 1, then times quantity of n plus 1. So, since nabulag na nato siya, ipang-cancel na nato ang magkapareha. So, we will cancel 9 to the power of n. Kani, cancel po nato ni siya. Then we will cancel also 2 to the power of n plus 1. Ana, since na-cancel na nato siya, mo na lang ning nabilin. Kay kaning 9n, kay resulta ni siya sa kaning 9 times n diri sa pikas. So, 9n all over 2 times the quantity of n plus 1. So, mao na ni siya ang ato ang pangitag limit. And then, since naman tay 9 over 2, ibulag nato na siya para kani ato ang limit, masimple na lang siya pangitaon. So, since our numerator and our denominator is equals, so, our denominator and numerator
Degree.
kay equal iyahang degree, so, mag-base ta atong sa guidelines to find the limit. Katong, if the degree of the numerator is equal to the degree of the denominator, then the limit of the rational function is the ratio of the leading coefficient. So, same man silag degree, then our leading coefficient kay 1. And then, our limit is equals to 1. Then, since naman tay gibulag na 9 over 2, so, i-times na nato siya. So, 9 over 2 times 1 is also equals to 9 over 2. So, since our r is greater to 1, which is 9 over 2, therefore, our L is greater to 1. So, to conclude, we will use this rule. So, if L is greater to 1, including infinity, then the series is divergent. This means the infinite series sums up to infinity. So, since the value of limit is 9 over 2 and it is more than 1, therefore, by the ratio test, the series is divergent. This means that the series sums up to infinite sum.
References. That concludes our presentation. Thank you.